do all 7, I'll do some there, and we'll go from there. Okay. Start out with the first one. Tell me what the expression looks like. And by the way, this does not say solve. It says factor this. Read that to me, and I'll jot that down.
2x cubed plus 16x.
2x cubed plus 15x.
Oh, 16. 16
Plus
16. X. No equals mark. I'm not solving this, just factor it. Guys, first, or between those two terms, is there a common factor? Can I divide both of those by something? That serves as a common factor. Can I take out a 2x as a common factor? Now, if I'm patient and I divide each one of those by 2x and do what I got to do, please tell me, do I end up with x squared plus 8? And I'm finished. That's it. If I use the distributive property for a check, that's it. We're done. Can't do anything else. Now, I might be able to do something else on another problem, but this one's finished. I just took out a common factor. Okay, tell me what the next one says.
x squared plus 2x minus 3.
Now, this one is more in line with what we've been doing. Now, notice it does not say equal to 0. Just factor it. This is more in line with you doing this. Parenthesis, in this case, x plus 3 as you try it. X subtract 1, and there it is factored. That's more in line with what we were doing when they asked us to go ahead and solve it. Okay? That one's done. Doing the next one.
5a squared minus 7a minus 6.
Minus 6. Okay? Maybe this one may factor. She says the directions say factor. I don't think it said use quadratic formula, did it? No, it just said factor. Let's try it again, this, which is more in line with what we've been doing. And we'll try 5a and a. Now here comes the issue. I gotta get a negative 6 on the end. Could be a negative 3 and a positive 2. Or a negative 6 and a positive 1. Some choices. But where to place them to make this thing work, if it does work. Anyone have an idea where to place what? What should I place where? Make this work, if it works. We'll put a 6 here and a negative 1 here. I don't know yet. We'll put a 3 here and a negative 2 here. I don't know yet. Or a negative 2 here, positive 3 here. You got choices. And sometimes textbooks will call this just a trial and error. You try and make an error and go back and change it to something else. Let's hope this factors. I would hate for you to waste your time trying and trying and trying, and you have one that does not factor. But I see a hand going up there. I thought, yes.
Oh no, I was about to say.
Okay, I saw another hand going up. Yes.
5a plus 3, and then a minus 2.
That definitely positive 3 times a negative 2 is negative 6. Now, the important part is, with what you gave me, Professor, if I check this out, that's a negative 10a. I think this part inside there is 3a. With those two combined to, and give me the middle term we originally had, negative 7a. That's her choices. And with the choices she gave, it looks like it completely checks. And those are the factors of 5a squared subtract 7a subtract 6. That's it. I'm not going to set those equal to 0. This is not an equation. It just says factor. Name the next one for me, please.
9b squared minus 36b minus 45.
Minus 45. Here goes again. Now you always look for a common factor if there is one. Up here, I think this one had a common factor. Does this one also have a common factor, something I can take out first? 9. Divide everything by 9. It is. So we're going to end up with b squared, 4b, and a minus 5. I always take out a common factor first, which we did. Now that b squared subtract 4b subtract 5 may not factor further, or may be finished. Or it might do this business, as we saw in some of the previous problems, it may go further. Put my 9 up front. Guys, I'll get you started if it works. Now, a B and a B for sure there. And what should I place where and make it work out. See a hand going up, yes.
-5 and +1.
-5 and a +1. That's definitely a -5. -5 times 1 is -5. And with what he gave me there, I see right here, the outside is a B, inside is a -5B. Yeah, if you put those two together, combine them like terms, that's a -4B, it checks. Please give me the correct factors there. And then I'm finished. I'm getting a little nervous because I recall now doing this worksheet for you guys. Letter E.
3x cubed minus x squared plus 6x minus 2.
This is why I said I'm getting nervous. Oh, and it says factor. And the reason I brought this one in for you guys, one of my colleagues who's doing calculus this summer, says he gave a diagnostic test to his students the first day. Just to see how they did, and he took it up and looked at it and said, oh, Ramsey. I said, what? I gave him a factoring problem that had 4 terms. And they said they had never seen it before. This one has 4 terms, and so they're asking you to factor it. So that's why I put this on yours. I didn't have it at first, and then I talked to him, and I make sure you saw it. Any ideas? Maybe you're like the other students, you've never seen it. Yes?
You split both terms.
Do it again.
You split both terms.
Now, when you say flip, are you saying flip?
Split.
Oh, split them up, split them up. When you say split them up, are you telling me maybe take these two and then consider these two? They're split up. That's called grouping. So I grouped the first two and I grouped the last two. That's what his calc students had forgotten, I guess. I'm sure they've seen somewhere. He said that was the most commonly missed problem on his diagnostic test. They did not realize to group. Now, if I've grouped correctly, I think in that first grouping, there's a common factor, at least I can take out of the first, of what, x squared?
X squared.
And that would be what, 3x subtract 1, I think it is, left over. In my second grouping that she suggested, I got 6x subtract 2. I see a common factor there I could take out, a 2. And up with 3x subtract 1 again. Now, I'm not quite finished. I got a plus sign. That shouldn't be a plus sign in there. Now, what should I do now to finish, Nikki?
We take x squared plus 2 and put it in parentheses, and then 3x minus 1 in another parentheses.
She's saying x squared plus 2, and professor, put that 3x subtract 1, and there's the answer.
No, we said
You just took out a common factor. By the way, do those two in the red right above there. Do those two in the red have a common factor of 3x subtract 1? So just take it out. She put it on the end, you put it out front if you wish, and you're left with x squared plus 2. And there's the answer. Okay, that's the one he said was being missed for some reason. They just forgot how to factor by grouping. Sometimes you gotta group. And what's the next one?
100x squared minus 9.
100x squared subtract 9?
Mm-hmm.
Okay. At least it's not 4 terms. Only 2 terms. Any ideas? I see some hands. Yes.
Both are squared?
Thank you. They're both perfect squares. First thing you notice there? Thank you. Now this one, guys, please tell me, is that like 10x squared?
Yeah.
The one on the end, I'm so glad you told me that, 9 is 3 squared. That's called a difference of squares. Another factoring technique. Since he has given that to me, look at how easy this is going to be done here. You're going to end up with 10x plus 3 in one set of parentheses, and 10x subtract 3 in the other, and you're finished. It's called a difference of squares. You add them in one set of parentheses, subtract in the other. You're finished. Now, if you multiply this out, you'll get the original blue. That's exactly what he was thinking about. Difference of squares, you're done. Okay, let me sit back and look at it. It looks good. Now, do we have one more?
We actually
and I'm getting a little nervous. If I recall me doing this worksheet for you guys. Is there a cube?
Yes.
Oh. Okay. Read that to me.
3x cubed minus 27x.
And they want you to not solve it, just factor it. And you always look for a common factor if there is one. Is there a common factor here?
Yes.
I could divide both terms by 3x, I think it is. If I take 3x out for my common factor and I know my division, we end up with x squared, looks like subtract 9, which is cubed. Then all of a sudden, x squared subtract 9, I don't know whether I saw it here or somewhere on all this work we've done today. I think that's another difference of squares that my student gave me earlier for the last problem. This is what here, x is being squared here. I'll put that there, and here 3 is being squared. So that will break on down. It's the difference of squares, like the previous problem was. So I got 3x out front, that's still there. And then the difference of squares will quickly give you x plus 3, x subtract 3. I love difference of squares. Easiest, one of the easiest factoring to do. You're done. They're just factored completely. Okay? Now, I know, she's going to read it to me.
Last one.
I may not do it today. I'm not going to be responsible for it today. I think it's the last one. Let me first put it on here and get some input from you guys, though. What is the last one?
8k cubed minus 125.
Oh. Get some input. Some students may recall. I see some hands going up. Oh, wow, I'm pleased. Yes?
They're both cubes.
Okay, they're both, oh, look at that. They're both cubes. Now, if they're both cubes, here we go. Absolutely. The last couple that I did were squares. He's telling me, no, professor, these are cubes. The first one I've got 8a cubed. Is that the same as this being cubed? So he's 100% correct. Is my 25 also a cube, like maybe, if you guys will agree, this? Yeah. It is a difference of cubes. Oh, I am going to do it then. It's a difference of cubes. Too bad it's not the same as difference of squares. I did a couple difference of squares on the board there. They're easier. Difference of cubes requires a formula. Now, I don't know how many students, I'm going to put it on the side here, recall this a cubed minus b cubed as a formula, and sometimes I know students forget formulas, but it's going to require that, when I finally place the formula on the board, it's going to require that to finish this up. But he was 100% correct. This is a difference of cubes formula I need. Does anyone recall for this summer class what the difference of cubes formula looks like? And then I will apply it to this and we'll be finished. Go for it.
Parentheses a minus b.
Oh, hang on.
Multiplied by a squared plus b squared.
Oh, almost.
Minus a.
Oh, you got more. B squared and what else?
Plus b squared minus ab.
Ooh, whoa, hang on. Close.
Plus.
I see, that's why I was going to
Plus
just not
2AB.
do this one today. No, but you're close. Good, close. Hang on a second. Yes.
2AB.
Tell again.
2AB.
Not 2AB. See, that's why this formula is so hard to remember.
A.
3a square b.
Tell again. A squared plus what now? What comes next? It's not 2AB. I would think it's maybe 2AB. It's not 2AB. It's just AB. Put that in. And what do you think is on the end?
b.
B squared. Now, who walks around and remembers this stuff? But you do. May take a little time to recall it, but you do. Okay, it's called a difference of cubes formula. And I'm going to apply that to this problem, and we are going to go ahead and see what this thing looks like factored with the help of that formula. Guys, do we recall seeing that somewhere in your history? From wherever? Okay, so it's a subtract b times a squared plus ab plus b squared. Now you said, Professor, what am I going to do here? The blue, I'm trying to factor the blue. Well, with the help, the student quickly told me it was cubes, which I did. So guys, this is like the a here, in that formula over there, and this is like the b. Now, can you, if I identify the A is like in this problem, 2A, and B is 5. So what would that look like if I apply it here, and that will be the factors? Start me out, what should that be equal to? 2A what? 5, got you. Now why did you get 4A squared? What did you say to do? Square that. So if I square that 2A inside there, what is that, 4A squared? I'm hearing?
4a squared plus,
This right here?
10a.
AB and A times B, that times that, she's perfect, 10A.
10a
We'll plug those two together.
plus, 100.
And plus it says on the end, square the B, and we identify the B as a 5, so if you square that, you get what? 25. Is that true?
I thought it was that, yeah.
Okay. You'll get 25?
Yeah.
Now, I know that closes that handout down for us. The last one looks a little strange, required a formula. What would you do though as a good solid student? What might bother you on this one before you actually turned your paper in? Because the answer is this. Strange, you know what? That's it by formula, a difference of cubes. What might you think may happen here before you turn your paper in if you saw one like this? What, do you think you can do something else with it? Besides what you see right now, do you think something else could be done to it? Is there something tempting here? Go for it.
I don't know, maybe a quadratic?
You mean right here?
Yeah, I guess, isn't
You
it?
mean that looks like it might factor further, just that part? I think, as a student, I would think so. I said, wait, Professor, I'm not finished. 2A, this is what I would think of as a student, I mean, that part right there on the end, that trinomial, would factor further. I know 2A, that's 4A squared, and for 25, maybe what, 5 times 5?
Yeah.
Well, I guess, Professor, why not factor it further, break it on down? And just go ahead and call it, hang on, just call it this, and when you get to USC, you have the answer as 2A minus 5 times 2A plus 5 squared, and at Stanford, they'll say, wrong. Don't tell them you came from SMC. Why can I not do that? Tell me, why can I not do that? It's so tempting. As a student, I would have done it. I would say, oh, come on, Professor, can't you take this on down like this? What's wrong with it? Why can I not do this? And therefore, I gotta leave the answer like this. Why will this right here not break on down? Give me an idea. Go for it.
The 10a.
Here we go.
The 10a.
Okay, hang on a second. I think I got it. This times this, check. This is 4A squared. Is that true, guys? 5 times 5, right above there is 25. Now, will this,
Is 1 equal to
that much right there is 10A. Inside here, is there another 10A? Combine them, how many do we have?
20.
20. I didn't have 20 here. I had 10. Boy, it looked like it would have gone down further, didn't it? No, therefore I cannot. Therefore the answer is what you see above there, blocked off. I can't take it any further. Looks like you could, but just wouldn't check. Okay guys, so that's a difference of cubes, which would require a formula. Now, you say, Professor, what are we doing now? what we're doing now, we're gonna actually start the course. Now, what was all this? I thought you started the course yesterday. Well, this is all, preliminary. My goodness. We're gonna finally start the course. We're gonna finally, look, I'll finally, I see that word I love so much, function. Yeah. This might, after all this that we did here, might fall right in line with what we did do, and might make the rest of the work for us, let me make sure I got everything correct here, work out much better for us now. Guys, we'll get a good start on this. Before I pass it out, I think you're gonna like this. This is where it really starts. They give you a definition, or I give you a definition of a function. We look at that definition, then we talk about functions and see what it's all about. And then I give you some examples here, and I think you're gonna love this. And then on the back, a graph, which is gonna represent a function, graph, and then some questions about that graph. Now this is where the course really, really starts. Yesterday, and what I've done today was just preliminary business that had to be done, just to make sure we know how to do it. Arena, would you pass these out maybe? Mr. Parker, are you okay there?